Hello great aspirants, welcome to part 1 of Electromagnetic Theory series. Question number 18. An insulating sphere of radius A carries a charge density rho of r is equal to rho naught in bracket a square minus r square cos theta, where r is less than a. The leading order term for the electric field at a distance d far away from the charge distribution is proportional to. So for this we will use multiple expansion and find potential first, and then from there we can calculate electric field. So V of r is equal to 1 upon 4 pi epsilon naught. Then first term 1 upon r integration of rho r dash into d tau dash. So this is basically charge. Plus second term is 1 upon r square integration of r dash cos theta into rho of r dash into d tau dash. This will be second term. Then third term is 1 upon r cube integration over r dash square into 3 by 2 cos square theta minus half into rho r dash into d tau dash, and so on. So all these terms will be there. So for this we have to find out leading order term. So first term is this. So we will calculate this integral first. So integral, this will give us charge. So charge is equal to integral over rho of r dash into d tau dash. So this is equal to integration over rho naught in bracket we have a square minus r square into cos theta, and d tau is r square sin theta dr d theta d phi. So this will be equal to rho naught is constant. First integration, this will be a square into r square minus r raised to 4 dr, and r is running from 0 to its radius, that is a. Then second term we have sin theta into cos theta into d theta, and theta will go from 0 to pi, and last term d phi, and phi will go from 0 to 2 pi. So this will be equal to rho naught. This will be r cube by 3, and by putting limit we will get a raised to 5 by 3. Here a raised to 5 by 5. Here we can adjust and adjust 2 here. So this will be sin to theta by 2. So this will be 1 by 2, and integration of sin to theta is minus of cos to theta upon 2, and limits are 0 to pi, and integration d phi is 2 pi. So this will be equal to cos of 2 pi minus cos of 0. So this will be rho naught in bracket we have here 2 by 15 into a raised to 5 into we have this 2 pi into 2, and this will be 1 by 4 with minus sign. So this will be minus of cos of 2 pi minus minus plus of cos of 0. So this will be equal to 0. So this first term is 0. So we have to calculate second term as well. Now second term is integration over rho into cos theta into d tau dash. So this will be equal to rho is rho naught into r square minus a square minus r square into we have cos theta and this cos theta. So this will be cos square theta into d tau, that is r square sin theta dr d theta d phi. So integration rho naught into we have integration over r. So this will be r is going from 0 to a. Then first term is a square into r raised to 4. Also we have here r here. So this will be r cube. So this will be a square r cube minus r raised to, this is 2 and 3, r raised to 5 dr. Then integration of cos square theta into sin theta d theta. Theta is going from 0 to pi, and integration d phi, and phi is going from 0 to 2 pi. So this will be equal to rho naught into, this will be integration of r cube, which is r raised to 4 by 4. So this will be a raised to 6 by 4 minus this will be a raised to 6 by 6 into, this is integration of function here is cos of theta. So this is fx raised to n into f dash of x. So this can be written as, we can adjust derivative here. Now derivative of sin theta is derivative of cos theta is minus of sin theta. So this will be minus of and integration of this. So this will be cos cube theta upon 3. And limit is from 0 to pi and d phi is 2 pi. So this will be equal to rho naught into bracket. This will be 2 by 24 into a raised to 6. And this is minus 1 by 3. And here we will have minus 1 minus 1. So that will be minus 2 here into 2 pi. So by multiplication we will get some constant. So this second term is not equal to 0. So this is the leading term. That means this second term will survive and it is proportional to 1 upon r square. So from here we will get V of r is proportional to 1 upon r square. And we know E of r is equal to minus of dou V by dou r. So here we have to take derivative of this. So 1 upon r square. So this will be proportional to 1 upon r cube. So here distance is d. So option C is correct. It is proportional to d raised to minus 3. Next question. Two magnetic dipoles of magnitude m each are placed in a plane as shown. The energy of interaction is given by. Now the interaction energy for two magnetic dipoles which are separated by some distance r is equal to U is equal to mu naught upon 4 pi into we have 1 upon r cube, and this is m1 dot m2 where m1 m2 are magnetic dipole moments minus 3 into m1 bar dot r cap and m2 bar dot r. So this is the formula. Here two magnetic dipole moments are magnitude m. So that means m1 is equal to m2 is equal to m. And this distance r is equal to d. And m1 is in vertical direction and m2 is in this direction. That means they are perpendicular to each other. So we can write m1 dot m2. This will be, since they are orthogonal, so this will be 0. And angle between m1 bar and d, it is here 45 degree and 45 degree. So m1 bar dot r cap, this will be equal to m2 bar dot r cap, and that will be equal to m in magnitude of m into magnitude of r into cos of theta. So magnitude of r cap is 1 and cos of angle, so this is cos of 45. So this will be equal to m by root 2. So we will substitute these values here. So this is equal to mu naught upon 4 pi 1 upon r cube. This is equal to 0 minus 3 into m by root 2 into m by root 2. So this is equal to minus of mu naught upon 4 pi r cube into this is 3 into m square by 2. So this is equal to minus of 3 into mu naught into m square upon 8 pi into r cube. So here distance is d, so r is d here. So option D is correct. Next question. Consider a conducting loop of radius a and a total loop resistance capital R placed in a region with a magnetic field B, thereby enclosing a flux phi naught. The loop is connected to an electronic circuit as shown, the capacitor being initially uncharged. If the loop is pulled out of the region of the magnetic field at a constant speed u, the final output voltage Vout is independent of. The final output voltage E is equal to minus d phi by dt, and it is pulled out at constant speed. That means this flux, whatever flux is flowing through that, it will be constant. And if it is constant, then Vout is independent of phi naught. It will not depend on phi naught. So option A is correct. Next question. Consider the propagation of electromagnetic waves in a linear, homogeneous and isotropic material medium with electric permittivity epsilon and magnetic permeability mu for a plane wave of angular frequency omega and propagation vector k bar propagating in the medium of Maxwell's equation reduces to. Now we know this k bar propagation vector is always perpendicular to E bar. That gives us k bar dot E bar will be equal to 0. So this first statement is correct. Then we have second statement. this k bar will also be perpendicular to magnetic field. That means it will be perpendicular to h bar as well. So that means k bar dot h bar, that will be equal to 0. But it is common in all these cases, so we have to check next ones. Now we know b bar is equal to 1 upon c into k cap cross e bar, because e bar, b bar and k cap, they are all perpendicular to each other. K cap is k bar upon k. So here I can write k cap is equal to k bar cross e bar, and in the denominator we have c into k, but we know c is equal to omega by k, so ck is equal to omega, so here I can write omega. So from here we can write k bar cross e bar is equal to omega into b bar, which is omega into mu into h bar. So here option, this omega into mu into h bar is correct. So option D is correct. We can check last one as well. This is first one. So from here we can also calculate E bar. Now E bar is equal to minus of C into K cap cross B bar. So this can be written as, K cap can be written as K bar by K. So this will be minus of C by K into we have K bar cross B bar. And B is equal to mu into H. So this will be minus of C into mu by K into we have K bar cross H bar. So from here K bar cross H bar is equal to K by C mu with minus sign into we have E bar. We can write this in terms of omega as well. So we have from here K is equal to omega by C. So this will be minus omega C square into mu into E bar. Now C is equal to 1 upon under root mu into epsilon. So that gives us C square is equal to 1 upon mu by E, mu epsilon. So here we have C square into mu, and C square into mu, that will be epsilon. So this will be minus of omega into epsilon into E bar. So this is also correct. So option D is correct here. Next question. If epsilon and mu assume negative values in a certain frequency range, then the directions of the propagation vector k bar and Poynting vector s bar in that frequency range are related as. Now we know k bar is parallel to E bar cross B bar, and Poynting vector s bar is 1 upon mu naught, and we have E bar cross B bar. But here it is given that this mu and epsilon, they are assuming negative values. So this will be negative here. So if we consider k bar and s bar, they will be along E bar cross B bar, but in the opposite sense. So they will be anti-parallel to each other. So s bar and k bar are anti-parallel to each other. So these were all the questions from GATE 2010 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.